Jamil, go ahead.
So the first question is, I don't have any knowledge about electronic manufacturing, but considering the price of snickerdoodle, the baseboards seem kind of expensive. Can you explain?
Sure, yeah. Well, I mean, I guess you can address this if you want. So yes, the snickerdoodle is, I guess a good way to put it is disproportionately more affordable, so to speak, than not only just the baseboards, but just most, probably your typical kind of electronics, DIY electronics product. The kind of course, the main idea behind, a big part of the concept behind this entire project and snickerdoodle in general, weird glare thing on here, was to make the kind of core technology as affordable as possible. So, what we ended up doing is kind of taking a lot of the components that might typically be included on an SBC or things like that, and moving those to baseboards. So for people who didn't necessarily want or need particular, whether that's specific interfaces or sensors or things like that, that they don't have to have them. You're basically fundamentally left with the core functionality of the device. So in this case, obviously, it's the whole ARM processor, the FPGA element, and then all your I/O and the wireless. So the other elements of the system, it actually kind of, in a way, it keeps it more affordable as you go between applications and between specific peripherals that you might need, because you can basically take the same little brain, being the snickerdoodle, and plug it into individual baseboards, depending on what your application or your project is. So instead of having to basically rebuy that whole side of it over and over again. So kind of the flexibility and modularity of it, on the whole, actually end up making it more cost effective. And of course, there is the element of volume too. A big part of it is we're selling, as you can imagine, we're intending on selling a lot more snickerdoodles than any one individual baseboard, just because those are going to be more application specific. So we don't get quite the same cost savings for volume components, manufacturing, assembly, all those kinds of things, as we do with snickerdoodle. So hopefully that kind of helps answer the question, but yeah, gives you a general idea kind of where we're coming from. There's a question on here. Oh, I saw one of the 20 questions I entered on here actually ended up coming through, but I think this is Rob asking if he has a list of questions, do you want them individually or in a pile? You can, if you want to put them on in a pile, it's fine. We'll just kind of go down the list and get to them as we can, and assuming they actually come through here. So I don't know what happened. Literally only the last of these 15 questions that I entered from other people came through. So I'll try and address that during this thing. I don't want to hold this up anymore. Well, here's a question. I may as well give this one. So I was curious if it was possible to just cut a square hole in the middle of the baseboards for the heatsink. Should make both the headers up and down options compatible with it. I'm not exactly sure about the second part of the question, but I see what you're saying. So basically loading that's interesting. Loading a baseboard from the other side effectively, I think is kind of what you're saying, is instead of the alternative being, flipping the connectors that would normally be pointing up the other way, which obviously has some issues as far as reassigning pins, basically mirroring everything, and then kind of more relevantly, the connectors still end up going somewhere, right? So I guess it's always possible to cut a hole in the middle of the baseboards. I mean, I can obviously, you're going to end up with
would it be like a hat, though?
Huh?
When he says baseboard, does he mean like a hat, basically, like it's going on top?
Well, yeah. So it sounds like I think it sounds like what James is getting at is you have say a connectors up version of Snickerdoodle,
Yeah.
and instead of having to have a separate version of it that you could plug into baseboards, basically have that same board that you can just stick a baseboard or a hat or whatever you want to call it on top.
Yeah, I think I can address that a little bit. I mean, there's been a lot of questions about the connectors themselves, and of course, I think in the FAQ we actually answered some of this about the female and male connectors. The male connectors that are the standard issue male connectors on the Snickerdoodle are male. I'm sorry, connectors are male, and they have male pins, and we face those up because it's the way that they're designed to be used by Samtec. The female connectors that we have as an option, we face down. They're actually the pinouts on the connectors. Samtec makes those with the pinouts reversed to be used in exactly the way that we're using them. So you have a baseboard or that has the male connectors pointing up and the female connectors pointing down, and then the pinouts all match. So everything makes sense. The Samtec system also has in addition to having a board-to-board interface with these male and female headers, essentially, you can use cables, and so we have to kind of keep that in mind in terms of maintaining the pinout standard pinouts that they have, because everything's keyed, right? So you certainly could do something like what's being described, but the overall cost wouldn't change the fundamental cost. The female headers do cost more because of the manufacturing process. I mean, that's how it was described to us by Samtec. For the female pins versus the male pins, and also that we're using low insertion force pins on the female headers. Otherwise, there's so many pins. It's a high IO count device. You would have a difficulty unmating it if we didn't use a low insertion force pin. So I don't know that directly answers the question. Of course, you could make like a hat, sort of, I guess is what you probably call it, with a hole in the middle, with female connectors, but that wouldn't kind of reduce your costs at all. What we've done on some of the designs is had the Snickerdoodle facing the other direction, so that the heatsink is pointing down. So same idea as what's being described. You still use female headers on the bottom of the Snickerdoodle and male headers on the baseboard, but the male headers are pointing down on the baseboard, and the Snickerdoodle is essentially upside down with the heatsink pointing down, and standoffs holding the whole baseboard up off of whatever surface it's mounted to. So. Did I cover the actual question there, Ryan, or not?
I think so. Yeah. In general, I mean, the answer, of course, is yes. You could. I mean, basically, you could do what James here is describing. I mean, of course, having a baseboard with the more expensive connectors and a hole in the middle of it is going to be a lot more expensive than doing it the way we're typically doing it, because it's actually that was one of the reasons why we ended up listing or providing the baseboard connectors on the campaign page, is we had a couple of people asking about whether or not they could, if they wanted to build their own baseboards, the connectors, if you go on Samtec's site, are still kind of expensive. So I think the price that we're able to provide everybody is almost equal to probably the price that you would pay for a single one of those connectors, maybe a couple of those connectors if you were buying them just direct. So yeah, I mean, you could do all sorts of different stuff. It's probably a little bit less cost effective and practical in a lot of situations, but yeah, I mean, I guess to answer the question, yes, it's possible. would we recommend it? I mean, it'll look cool, but I don't know if you're going to get too much of a benefit out of it.
Yeah. Yeah, and you got to keep in mind too. It's whenever you're stacking things. I've run into this before, where we build big stacks of boards. The heat from the boards underneath will stovepipe, and so you either need to have some cooling that's going left to right, like transverse cooling. Something to keep in mind is that you're kind of blocking convection, and so on the probably the highest heat generating component is going to be the microprocessor and the FPGA if you're using that in a high performance kind of application where you're really using all the resources. And generally speaking, it's a good idea to have that on top so that you have the natural convection. And the heatsink that we're using actually is good for the copper heatsink is good for airflow in any direction. Yeah, that's another thing to keep in mind, I suppose.
Cool. All right, let me figure out how to mark this thing answered.
Are we able to see those questions? Because I can't see the questions. So.
I don't know. This thing is not working exactly as expected, but there was, when I started answering that question, a little thing that could mark the question being answered on the sidebar. I think if you click off the Q&A thing and back on, you can see it, but I can see directly that not all the questions that are being posted are showing up on here for some ridiculous reason. So, all right. Well, I guess that question's answered at least.
We have a new question. We want to take one from the grab bag.
Yeah, so we can. Well, first off, I guess I kind of skipped over this at the beginning, but just a real quick introduction. So my name's Ryan Cousins. I know maybe some people caught me on Floss Weekly, the This Week in Tech podcast, video podcast, Tuesday. Tuesday. So anyway, one of the team members, and then Jamil was the one just talking there, and then Russell, or we call him Bush, is in the purple shirt there. So we figured this would be a good opportunity to come on and introduce ourselves, sort of put a face to the name, see that we're not just, I don't know, internet bots or something like that, and answer a few of your questions, of course, about Snickerdoodle or just, I don't know, the project in general, projects, all different kinds of things, kind of as much stuff as we can get through. Anyway, back to these kind of questions, I guess. So some people had asked about recently we had a few questions about some of the baseboards that we had posted on the campaign page and now have magically disappeared. So those being Gryphon, the autopilot baseboard, whiteRhino, which was the kind of industrial SBC controller kind of thing, and the third was the shieldBuddy, the little Arduino shield adapter. Maybe some people watching this have never seen any of those, depending on exactly when they kind of hopped on board or whatnot. But in any case, so those three boards ended up being taken off the campaign just because of basically there's a limited interest, and also especially for the Gryphon and whiteRhino, there was going to be a pretty substantial cost to both producing and developing those. So for now, we've kind of put those to the side. The whiteRhino schematics are still posted on our GitHub. Just GitHub/krtkl or github.com/krtkl. So it's a good reference design, and we actually moved the networking portion of that, so basically the gigabit Ethernet ports to giggleBits, and then added on a couple other things, and made it much more affordable than the $500 that the whiteRhino originally was. Gryphon is a project we're still working on. We've contacted people who are interested in it or pre-ordered it before, and we're working on kind of going through a slight redesign process of that, just kind of getting some community feedback in terms of what would be valuable to have on an autopilot with Zinc or Snickerdoodle installed. So it's a project that's still alive and well. And then the Arduino shieldBuddy is still something that we could consider bringing back if there are enough people interested in it. So if anyone wants to, send us an email or post somewhere or whatever, even post on here that be interested in adding that. We had some good feedback definitely from people with different ways to go about doing that, basically supporting Arduino shields. But in any case, that's something that the design's done and it's basically ready to make. So even if other people want to make it, that's something we could support as well. But anyway, for the time being, that's just something we took off to kind of lighten the campaign a little bit, clarify the message, and then assuming, this ended up actually being pretty good timing, just coincidentally. Looking at the thing now, we're at 97% funded. So. I don't know. We'll have to do something crazy if we end up funding while this thing's on air. But once we hit this first milestone, that'll obviously be huge. Super excited about that. And then we'll be bringing up the kind of first stretch goal, which is like a people's choice shield or baseboard type deal. So that could be something that we already had on there or something completely new. So start drumming up some ideas for that. We'll obviously be reaching out, taking votes or whatever you want to call it, and figuring that out as kind of as we go. Let's see here. I guess he's reading kind of from the bottom up. Okay, so yeah, this is the way that Google's done. This is not anyway. So. All right, here's one from Rob. It's Rob. We hear from Rob a lot. We like Rob. This is E. Well, okay. I don't know what this is. This doesn't make any sense. All right. Well, in any case, this is going regardless. So the question was: I don't know if anyone can even see which question I'm answering or what's going on here, but in any case, is the base 7010 Snickerdoodle plus 1 GB upgrade plus 5 GHz Wi-Fi upgrade gone for good? So yes and no. I think I believe. I don't know. Maybe not correct me if I'm wrong. I guess you can't really say anything. But if you ordered, so the way that we started the campaign or the structure around Snickerdoodle out at the beginning was basically giving all the options to everybody, so anyone could configure Snickerdoodle kind of any way they wanted. It ends up being kind of a little bit hectic when that happens, and of course there's a ton of SKUs that come out of that. So it adds a little bit of confusion on the fulfillment end. What we ended up doing is kind of making this kind of delineating separation of we now call Snickerdoodle Black and just Snickerdoodle. So the primary difference, of course, being the SoC, so the main Zinc part on there. Snickerdoodle Black has 3 times the programmable or reconfigurable gates, faster processor, and then the additional things that we added on there was, it kind of made sense if people were, I think, of all the different configurations of products that people were ordering, I think there might have been one person who upgraded the processor or the SoC and didn't upgrade to 1 GB of RAM, which kind of makes sense. So we just included that, and we bundled in the wireless, the 5 GHz or dual band radio into that same bundle. So it was just a situation of kind of, I guess it makes it a little bit easier to, of course, make decisions when you have fewer options kind of deal. So, in terms of basically kind of simplifying everything and still providing 95% of the options that people might want, That ended up being the easiest way to do it. With all that said, we have, if you have ordered one of those configurations of, maybe something that's not offered anymore, like this, 7010 plus gigabyte plus a dual band radio, that is, you'll still end up getting that product, unless you decide to cancel it and upgrade it or whatever you want to do there. But any configuration you've ordered, you'll get. We'll make sure that ends up being the case. And in the future, we'll kind of have to see what options actually end up making the most sense for people. Especially when it kind of comes to wider distribution and things like that. Having fewer SKUs is much much better in terms of retail stores or people stocking them on a DigiKey or whatever it might be. So that's something we're definitely going to work out at going on. If people have specific applications that require, say, a 7010 with a dual band radio or something to that effect, that's something we're definitely, we're for sure open to working with you on. If you need to order a bunch of them, it's not a big deal for us to support that, of course. So anyway, hopefully that kind of answers the question. But yeah, so it's just kind of a sort of a different. Just wanted to kind of simplify things a little bit, and clean up the product offering in general. So that one's done. All right, maybe that question might have actually worked and gotten answered and been tagged. So I guess we'll find out later. But okay, here's one. Well, yeah. So this is one question we've been asked quite a few times. Are you planning to post any tutorials or demos? Bush might be able to comment on this a little bit, but it's definitely something we're working on actively. Of course, in the long term, we expect to have just a boatload of course, examples, demos, tutorials, documentation, all kind of stuff that kind of gets you up and running, kind of introduces you to the product. How do you get a light blinking? How do you get a motor turning? Things like that. So we're working on those. Of course, things are a little bit resource limited at this exact point in time, because we're also putting a lot of focus on the whole tool chain in general, and the overall developer experience, to make sure that that's pretty much as expected and as robust and kind of as strong as that can be. But yeah, certainly in terms of education, getting started, things like that, it's certainly something we're working on, and we're actually even working with some of our alpha customers to help us build some tutorial videos, to put some example code up on GitHub, come up with different applications or projects, and which is something we'll be rolling out even a little bit more here in the next couple weeks. But I don't know, Bush, I don't know if you had anything to add.
I mean, for anything like this that's sort of aimed at this particular community, the whole idea is to have the community sort of supporting itself, right? That eventually we'll get to the point where people are posting stuff all over, GitHub, posting stuff all over Hackster.io and Hackaday, and just putting all the krtkl and whatnot, just putting their thoughts and their projects and their ideas, just sharing with everybody. But obviously initially a lot of people do that. A lot of people make Arduino clones and whatnot, and the huge deficit with that sort of that we see in general is support, right? That not a lot of people are actually seeding these projects initially and sort of showing people what can be done. So that's sort of our aim initially, is to sort of put out there some tutorials in terms of the actual how you actually do the development, and then additionally taking it one step further and showing people once you've learned the tools, once you've learned the actual hardware, how do you actually put together a particular sort of example project? How do you blink an LED? How do you run a motor? That sort of thing. So that's sort of what we're working on putting out right now. Putting together some sort of educational demos, tutorials, if you will, on the actual, like you're saying, the sort of user experience, and how do you actually pull the thing out of the box, how do I, once on whatever machine I'm using, how do I actually plug in what I need to plug in to get something, sort of rudimentary working, to sort of blink a light, hello world, that kind of thing, so that I can see something alive, right? The Frankenstein's monster, right? And then beyond that, how do you actually do something a little bit more sophisticated? How do I actually go from the hardware itself, the actual hard board with some connectors or whatever sort of arrangement you want to set up, to running a full-fledged robot? So we're sort of going to try to piece things together from one end to the other, and that's something that we're definitely working on, and that we're planning on providing support for, right? That we don't want people to just be sort of lost when it comes to this thing, because that's not going to be good for anybody.
All right, good stuff. Okay, let's see. Let's see. All right, here's one. So what do you make of the split between the sales counts for the base versus black editions? So
I can answer that one.
Okay, sure. Yeah, go ahead.
So okay, the base, as we said before, the base and black are the distinction is that the snickerdoodle, we don't really call it a base. That's not really fair to it. It's pretty capable. So it's the 7010, and the snickerdoodle black is the 7020. That's kind of how we're defining those. The split is approximately 3-2. The numbers on the crowd supply page aren't quite exactly right because of the way that we initially had the configurations being done. And when we changed that, kind of messed up the total count is right, but the way it was split wasn't exactly right. But it is essentially, we've seen a very consistent ratio of, for every 3 7010s, there's 2 7020s, which was pretty actually surprising to us in terms of that, and it's the audience. I think it kind of depends on the application. For more advanced application, people seem like they're wanting the larger amount of programmable logic. It's about 3 times programmable logic on the 7020 over the 7010. We also decided when we were kind of developing the product that we would do a extended temperature -3 speed part for the 7020, which I don't know that many of the other Zinc boards that are out there are actually using that part, just so that there's a real distinction between the two parts that we're selecting for the snickerdoodle. I don't know that I really make anything of it, except that different people have different kind of objectives. If you're looking for something that is more comparable in price to a Raspberry Pi or Arduino, then you're probably going to buy it as snickerdoodle. If you're looking for something that's more comparable in price, or kind of more into much more expensive kind of FPGA or SoC based boards, then you may pick the black. I think that's all I really make of that. You have any kind of input on that additionally, Ryan?
No, I think it's no. That kind of summarizes. I mean, I think it's actually in a kind of a funny way good that that we are seeing more blacks initially go out the door, because I think in general a lot of the people who are selecting the black versions kind of are probably already relatively familiar with either the kind of specific platform or technology, and have a very specific thing that they're looking to do with it, which in terms of the community development is going to be really powerful. Kind of getting those units into people's hands to kind of show what's possible with people who are maybe been doing FPGA development or something like that, that's a little bit more advanced than just kind of the basic functionality. Having more of that out there sooner is really going to, I think, give a nice kickstart to the greater kind of community of snickerdoodlers, if you want to call it that. So, which we're working actively with our alpha users and stuff like that to get units out by the end of the year, so people can start building demo applications and tutorials and all that kind of thing for everyone who's going to be getting their boards in March. And the idea, really was to make this a product that you didn't have to have super specialized knowledge of FPGAs and SoCs and all this kind of hardware level sophisticated stuff. That was a huge driving force, just the development of the product in general. Whereas if you wanted to get into that kind of more hardcore stuff, doing hardware acceleration or custom IP and all this kind of craziness, you could do that, but it's also kind of supplemented, if you want to call it that, by this kind of greater community of builders and makers and creators and roboticists, students, engineers, whoever, that are building these projects, have all these super cool ideas. They can then kind of pull from all this expertise of people who might have been doing this stuff for their entire lives. So it's kind of a different, in that sense, it's quite a bit different from even like a Raspberry Pi or Arduino, where there isn't too much like upward mobility, so to speak. These are really professional, commercial grade kind of tools that you're getting basically to build your own projects with on a budget. So having these kind of two groups, of the black and just the snickerdoodle is kind of accentuates that, I guess. So it'll be interesting to see how that plays out over time, and maybe as more and more people figure out kind of what's possible, having the extra resources of the black version, and how that kind of corresponds or correlates directly to their own projects, that might become more and more appealing. But we'll see. The bottom line was, it's $55, and that's all you need to get going. Which wire some stuff up on the bench, and you get some in Frankenstein in a couple days, kind of thing. So not having it be this sort of more exclusive, developer tool kind of thing.
And I'll point out another thing, just technically, because probably people are kind of wondering. One of the things that you wonder when you first start out with FPGAs is, well, how many gates or how many logic cells does it take to do this or that? There are a lot of resources online that show resource usage for various different applications, and some of the recent kind of open source products that have integrated FPGAs. A lot of times those things are Spartan 6s, and I'll just point out like one of the more popular ones was like the LX9. There's a couple of boards out there that use LX9s. That's a 9,000 LUT, I believe. I'm sorry, I don't get it quite right. 9,000 logic cell device, and that's the bottom end, or the base snickerdoodle, whatever we're calling it, is a 25,000 logic cell device. Well, no, say 16,000. I'm getting confused. I'm sorry. But my point is that you can take a look at applications that have been done with Spartan 6 in kind of the open source community to get a sense of what you can do with the FPGA portion of the Zinc in the snickerdoodle. It's very capable. That's all, really. So
cool. All right, let's keep the train running here. I just saw one here. Here's one from Rob again. I don't know much about BLE. Is it always operated in a paired mode, or if I have a handful of devices in a small space, can they all send and receive packets to one another or broadcast? Neil being our resident wireless and BLE expert, I'll let him take this one.
Yeah, the BLE is a little different. Is obviously it's called Bluetooth, right? But it was actually developed outside of Bluetooth, and I think they brought it into like the Bluetooth standard. It is designed for what was the second part where you described there, kind of being able to view, have a bunch of devices. It's not really. I don't really think there's different classes of BLE devices. The way that it functions is different than Bluetooth Classic. So yeah, you can. I mean, one of the applications, of course, that to just kind of demonstrate this in a kind of a real world way is a little. I don't know if you've ever seen like the little tags that you use to find stuff, like Tile. There's some other things like that out there, and where you can have like a app on your phone and tie these little BLE tags essentially to various things that you don't want to lose, and it'll basically say, your keys are over here or whatever, they're X number of feet away or whatever, and this other thing, your tag is over here, and you can see all of them at the same time. So yeah, it is that is the way that it works, the way that he described the second part of that question.
Cool. All right. Let's see if I don't know how that question actually got marked, but whatever. One was, oh, yeah, this is a good one. Unfortunately, I don't know what's going on. I can't upload some of these questions, so apologies for them. They're just going to be kind of shoved in the middle of the video, so hopefully somebody takes an hour to watch the thing later. But so there was a question about whether or not the baseboards or any of the baseboards require FPGA IP to function, and if so, will we be providing that? So again, Jamil, you can probably address this one pretty easily.
Yeah, so it's intentionally we're trying to so because of kind of the audience that we're aiming the platform at, we're intentionally have designed it in a way to wherever possible not require the FPGA IP. Right, so that is kind of it's an enhancement, The one area currently with the 3 baseboards that we have, the breaky board, which is just a breakout, of course, it doesn't require FPGA IP, right? The piSmasher and then the giggleBits. The piSmasher, the portion of that that's doing the HDMI in and HDMI out, is really the only portion of that board that requires FPGA IP to function, and yes, it will. The IP will be provided to the people that buy that, basically. So that answers that question, I think.
Yep. All right. Okay. Here's one from Rob. Really, Rob wasn't kidding. He did have a gigantic list of questions. So this is cool. Thank you, Rob. So for someone to take reference designs from your GitHub and alter/clone/modify them, what PCB toolchain makes sense to use? I mean, we do our layouts in pads. So I mean, I guess that would probably be the most directly usable tool chain. But I don't know, Jamil, I don't know if you have any recommendations.
Yeah. Well, so that actually, I remember I was watching one of the Floss shows, and that particular question came up about a lot of the PCB tool chains. Obviously, we use like OrCAD and pads primarily as our tool chains, just carrying over from kind of professional stuff that we've done in the past. But there's a great point, is that those things are kind of expensive. And so, I don't know that I've done a little bit a number of years ago, Eagle. I think they're still pretty cost effective. I don't know about the portability, though. I know that pads layouts are portable into, say, Altium, but I'm not really sure about Eagle anymore. I don't have that information currently, so if someone out there has that, we'd be happy to hear from them. And there are a couple other kind of low-cost sort of layout tools. But I mean, right now we primarily use pads, pretty much almost exclusively for the layouts, and OrCAD on the capture side. So that answers that.
Yeah. We're definitely interested to hear if other people have tools and things like that they'd recommend, that are open source or free or cheap or whatever. Yeah, definitely be interested in hearing about anything that anyone recommends. So it's done. Let's give it. James mentioned is a makeables.info site. Looks like kind of a central location for posting projects and tutorials and things like that, so people can check that out. I don't know if it's kind of similar. It might be kind of similar to Hackster.io and some of these other types of websites are doing similar kind of stuff. But anyway, something to kind of take a look at there. Let me see here. There's this thing. Do you have any recommendations for FPGA learning resources? So yeah, there are quite a few good examples or good resources out there. One that we always direct people to. It's a little bit of a higher level, of course, than learning how the kind of nitty-gritty elements of programming and doing kind of design work with FPGAs. But there's a book called Zynq book. So if you call it ZYNQ, zyncbook.com, it's actually a freely downloadable book that the folks at University of Strathclyde worked with Xilinx on to basically create a free resource for people working with the Zynq parts. So it kind of gives you an introduction to kind of the there's a link to it. There's a couple links to it in our campaign and everything. But it gives you some really good introductions as far as to the parts themselves, kind of what they're capable of. Yeah, or you can always get the print copy on Amazon for those who like to highlight and take notes and tab and all that sort of stuff. But and then I know, Jamil, you mentioned before this you had another one or two other books that you recommended.
Yeah. So yeah, the Zynq book is a really good one. A lot of the questions that we get have to do more with the architectural specifics of Zynq because it's an SoC because it's an FPGA SoC and it has the microprocessor side and it's integrated, and that's something that I don't know that fewer people understand how that's really been done and how tightly integrated it is, how really excellent it is. But if you're just looking for a FPGA resource in terms of doing like a hardware description language type approach, to development, RTL, that sort of thing. The book that I recommend as a starting point is actually written by this one of these written by this. It's a little old. It's based on Xilinx parts, Spartan 3 parts. I guess this is a 2008 book. It's by this guy, professor at, I think he's at, I don't want to misquote, but says Cleveland State University in Ohio. So Pong Chu, it's this book here. There's two versions of this. I guess it's backwards in the picture, but there's two versions of this. One is for VHDL. This is the one I have. And then the other one is for Verilog, and it's just called FPGA Prototyping by VHDL Examples. The other one's FPGA Prototyping by Verilog Examples. I think he wrote them in parallel, basically. And it was written, this is all developed on Spartan 3. Spartan 3 was the FPGA, Xilinx's FPGA line before Spartan 6. And then I guess sort of like Spartan 6 and Vertex 6. And then that was before, so it went like Spartan 3, Spartan 6, and then RTX, which is basically the Zynq parts that we're using, or the FPGA part of the Zynq that we're using. So it's 2 generations ago, but fundamentally very similar architecture. The Spartan 6 and the Zynq use 6-input LUT, whereas a lot of the original architectures used 4-input LUT. Really not that important. That is an interesting thing, though, that brings up an interesting point, is I did look up while we're talking, and I said something about the logic cells and comparing Spartan 6s to the Zinc. So officially, the logic cell count on the snickerdoodle is 28,000 logic cells, and it's 85,000 logic cells on the snickerdoodle Black. But there's a little bit of there's a little bit of a funny way that these counts are done, because a lot of traditional architectures use 4-input LUTs, and now Xilinx has used 6-input LUTs in Spartan 6. And so they're using a factor to adjust for the fact that logic cells were a certain size before, and now they're a bigger size. So when you look at the lookup tables, it shows 17,500 lookup tables, which is or 600 lookup tables, what we show on our website, and 53,200 lookup tables, but these are 6-input LUTs versus 4-input LUTs. So if you're comparing, it can be a little tough to compare. But the point that I was trying to make before is a 28,000 logic cell device. I believe the LX9 was a 9,000 logic cell device. So I think in terms of other FPGA resources for more advanced, as you get more advanced, and actually they're probably mostly given as references in that book, are like the Pongchu also did some RTL hardware design books that I think were written before the prototyping book. And then, of course, if you're doing VHDL, there's Peter Ashenden wrote a book on just VHDL, which is enormous. And there's a variety of books. Those are more advanced texts, but I would recommend the Pongchu book if you're starting out, because it just jumps right into doing something, basically, and outlines like the parts of language that you actually need for synthesis, as opposed to the parts that are for modeling.
Cool. Yeah, we can, once we figure out how this thing all posts and everything, we can definitely add some just direct links for these resources that Jamil mentioned in the notes or comments or whatever you want to call it. Cool. We'll stay on. We started a few minutes late, so we can stay on as long as we want, but I doubt people want to listen to us talk all day. So
we were about 10 minutes late. Start actually.
yeah, we can add a few more of these. Let's see here. Rob asked another question about the whole Vivado situation, and this kind of ties into another question somebody else had about some of these other FPGA boards, Xilinx FPGA boards, coming with these node-locked and device-locked licenses of Vivado Design Edition. And then Rob asked, is Vivado's board aware? For somebody that recognizes some of these other boards, and can Snickerdoodle Black become part of that collection to make it potentially easier to start a project? Obviously they're using the same family of parts, so it's inherently not very difficult in terms of we're working with Xilinx. Right now on getting through all the details of the specific tool combinations, everything like that we're going to be obviously supporting. So we do have some. It's been so yeah. Well, we can't really officially, I guess, talk about some of that stuff, but we might have some pretty exciting news about that coming up. But I don't know. There's unfortunately not too much we can say until it kind of becomes official. But stay tuned regarding the whole tool chain thing. As far as the whole node locked, device locked kind of business, Jamil can probably talk a little bit further on this, but it's true that some of the other boards do support that. It usually comes at additional fee for the specific device. But Jamil, you probably, I think you have some comments on that.
Yeah, the way that there's three different, like, right now the way Vivado is broken up is there's three different editions or whatever. There's the Webpack edition. The Webpack edition supports all of the parts that we're using. And pretty much for any kind of entry-level boards, pretty much would support those. There's the design, I think it's design edition, and then there's the system edition, I think there is, and those are, you know, they're licensed in different ways, and I don't think I've ever seen a system edition voucher, though I'm sure it exists. Some of the other boards will either come with, or like Ryan said, have a fee that you pay, or a little extra you pay for a kit for a voucher that, you know, lasts for a year or whatever like that for design edition. And the thing that really design edition mainly adds in the context of these parts is what's called a virtual logic analyzer for the programmable logic side of things. And like Ryan mentioned, we are looking at that certainly in other things. What I've seen done on some of the low-cost boards is that there'll be a version either that includes it, or there'll be an extra little kit you buy. The reason being that if you have a voucher and you have 10 boards, you don't want to pay for 10 vouchers because you only need one voucher for your workstation, right? So that's that is the main reason we're not. That's one of the reasons why we're obviously not including that in the price of the snickerdoodle, because that would just drive the cost up for all the boards. So the more expensive boards, like when they have these, you know, $800 or $2,000 kits, they always include some voucher as part of their price because they're very high priced. So there's an element there. But I will say that the Webpack does support everything that you would need to do to have the part function. I don't know, was there more to the question that I didn't answer there?
No, I think that's, I believe that pretty much covers it.
Yeah.
That's cool. Just probably a few more minutes here. So Rob, we probably won't be able to get to all of Rob's questions here, but I've copied those down, so maybe we can just post those into the forum and address them that way, just to make sure we get them all answered and addressed. I can provide it. It's on our website, krtkl.com. It's on one of the, however you get there. Maybe just, I can't remember exactly what the URL is, but anyway, you can just kind of navigate around the page and find our forum pretty easily. Let's see. I'm just trying to think of any other really specifics. There's some other questions that some other folks added. We'll probably have another one of these in, you know, a week or two. At least one or two more during the campaign. For either questions that didn't get answered, or new stuff that comes up, or if we have some kind of announcements or whatnot. There was one pretty cool one that I did want to mention, which this is kind of a, I don't know, at least I like this question anyway. You know, I'll probably just do these last two and then wrap things up. But one was, can network packets received via wired connection with piSmasher or giggleBits or over wireless be intercepted and manipulated by the FPGA before they reach the ARM cores in order to implement something like a hardware firewall or router? So Jamil, I figured you'd get a kick out of that one. So
yeah. So yeah, this was a really it was an area of deep consideration for us, because of course, you know, given the audience that we're targeting with the product, kind of this, like Ryan said before, kind of, you know, on the engineering side, but also kind of starting out, we want to make sure that the product's very usable out of the box, you know, and it's not overly complex. So there are definitely boards out there, FPGA boards. There's some pretty expensive stuff out there actually that is just nothing but FPGA surrounded by gigabit ports, you know, sort of thing. Right, and that's requires quite a bit of, you know, advanced knowledge to get going. Fortunately, the way the Zinc is designed as an FPGA SoC is that there's internal buses that are called they're AXI. This is standard. This is the ARM bus standard. People who are into FPGA stuff and doing integration kind of know about that stuff. It's an open standard. It's not open. It's open. It's a freely available standard. You can go download on ARM's website. But basically, the peripherals, so that includes the gigabit Ethernet MAC, that the 2 gigabit Ethernet MACs that are built into the Zinc are sitting on the AXI peripherals, and there's a central interconnect internal to the part that's basically like a big switch, a bus switch sort of. And that interconnect, there are what we call AXI slave and master ports that actually go into programmable logic, to the programmable logic side of the part. So you definitely can synthesize programmable logic in the FPGA side of the Zynq, this is one of the reasons why the Zynq is just a superior solution to having a separate processor and FPGA, like is done very often. You can definitely synthesize programmable logic that directly interacts over the AXI bus or AXI interface through the central interconnect switch with the gigabit Ethernet MACs that are built in, so you don't have to realize those in programmable logic like a lot of these other FPGA boards are done. So you can do that, or you can also, as a starting point, not do that and have the ARM cores talking to the gigabit MACs, because it's all on the same central interconnect. So certainly that's a more advanced approach than doing it all in software, or doing it all from the ARM core, or maybe bringing the traffic into the ARM core and then sending it to programmable logic and getting the result. There's a lot of different approaches to moving data around inside of the Zynq chip, and it's one of the things that I really recommend people read the Zynq book about that. And also there's some, we put up some, I think we put some answers up on the forums with regards to, we got this question about DMA. It's kind of started like, well, what about DMA? Can you do DMA this or that? There's a section of the technical reference manual for the Zynq that covers all these calculations of bandwidths and different ways that you can talk to different peripherals. There's special, like for instance, special mechanisms, high bandwidth mechanisms for talking to the or sending data to and from the DDR subsystem versus the peripherals. So there's a lot of mechanisms built into the part for this sort of thing, for co-processing. And in fact, there's even something pretty cool. This is pretty advanced stuff, so not something you would start with, but there's a cache coherent interface from programmable logic to the cache subsystem of the processor, so you can build these very tightly integrated accelerators in a device. So there's a lot of potential with the device that is really, in a lot of applications, not even realized, because right now there's kind of a limited audience. But part of our objective with making this more accessible is that the audience grows, and we see a lot more these interesting things being done with the way that this part is designed. So yeah, I think that hopefully that answers it. The answer is yes, though, to the question.
Right.
So, it's not the way you start, but the answer is yes.
So. Yeah, very cool. So we probably wrap things up here.
I got one thing I wanted to point out.
Yeah.
So you did mention in the beginning of the call about the Gryphon, about the autopilot, and us trying to do some rethinking of that to get it to be more, kind of attractive and, address the audience out there for that. So if anyone that is listening in or whatever has input on that, we encourage you to email us, either through the crowd supply or through, I think it's like hello@krtkl.com or whatever on the website, because we may be doing like a forum just for that, in terms of maybe driving the development or revision of that design from the community, as opposed to something that we kind of came up with, right? So that's something that we encourage you guys to email us if you want to. So
yeah, for sure. Yeah, we're I don't know, throughout the course of this thing, we've gone from 95% to 98%. So it's almost just worth staying on until we get there. But we'll drive everyone crazy here. I guess the last, probably wrap it up with just kind of a cool question, which is, what is your dream application for snickerdoodle? So I'm sure we each have our own take on this, so we'll just kind of go around the circle, so to speak. I guess I'll start, I suppose. I'm kind of a sucker for flying things. So either seeing this thing in a drone, or if I mean, something that would be really cool is if someone wants to put this in one of these little affordable satellites that people are kind of launching these days. Don't quote me on any sort of regulatory issues that might come up with you launching a satellite into space, but having some sort of snickerdoodle powered satellite, I think would be really cool, and might even be something we'll consider hosting some sort of Google X Prize version of something like that for snickerdoodle. But that would be my thing. Having snickerdoodle in space, I think, is kind of at the top of my one of the things at the top of my list. So, Jamil or Bush, or what do you guys have?
Oh, Bush, yeah.
I mean, I'm a big automation guy, so I mean that's sort of like where I come from is systems engineering, like robotics, right? So, the professional sense, that's always typically just automation. You're always trying to like automate somebody out of the workforce, right? But one of the things that I always have been sort of a big fan of is the Amazon distribution center, where they've got all these robots running around and they're all trying not to bump into each other and whatnot, moving everybody's stuff around. And obviously, snickerdoodle being completely wireless, having like an enormous amount of I/O, enormous amount of computing power, customization. I think that's sort of an ideal application for that. Having a bunch of things running around, talking to each other, all with their own little individual task. Just sort of your little army of robots, your swarm of robots, running around, doing whatever, cleaning your house for you, doing your laundry, whatever it may be. I think that's kind of a cool thought.
Jamil?
Yeah. Well, some of my ideas are kind of far-fetched, as you might guess. But one of the things that it's not really possible right now, but it's possible, like technically, from a hardware standpoint, but not necessarily the software tools aren't really there yet for this. But the programmable logic in the Zinc is accessible, obviously, through like a device, say in Linux or whatever. You can reprogram it or whatever. And I think it'd be really interesting to have some kind of scheme where logic was like evolved, sort of like genetically, like some kind of a genetic algorithm for evolving logic, like kind of on the fly or during runtime or something like that. That would be pretty interesting. I don't know how it's a little far-fetched, but theoretically possible, right?
Yeah, I'm sure somebody at a university out there, with a couple of R&D dollars to spend could.
Yeah. So.
Cool. Yeah. So we're almost there, everyone. I guess keep spreading the word, doing all that kind of good stuff. Again, we'll extend the thing, I don't know, for another hour if you want to just mention the word Hangouts in your checkout. Get $10 off an upgrade or baseboard or accessory or whatever. And keep it good stuff. And 3.5 weeks left, give or take. So right after we're just gonna blow through the goal, I'm sure, and then after that we're gonna get into some really fun stuff. The next stretch goal will be another cool baseboard that we'll tap into the kind of community for, and then after that we got some even better. After we hit that stretch goal, some even more exciting stuff that I think everyone will get a kick out of. So anyway, we'll wrap this up, I guess. Thanks for joining us. We'll send out some more updates and let you know when we're hosting another one of these. When we post it, we'll have to figure out how all this stuff works, but we'll somehow get this online so people can check it out and share links to it and whatever else. So all right, guess that's about it, and we'll talk at you I guess next time. So all right, bye everybody.
Right.